Assalamu alaikum guys. Again Dr. Kamran here. Today the topic of discussion is continuation of the functions in advanced microeconomics. In previous lecture we covered the topic how you can define the concave function. So now we are moving towards the function of quasi-concave. But before starting the concept of the quasi-concave function, we should clear about some important concept of the linear algebra. Acha, everybody has always a question in his mind कि why we discuss here the topics related to the linear algebra. देखिए लीनियर अलजेब्रा यूटिलाइजेशन ऑफ द लीनियर अलजेब्रा particularly in microeconomic theory is very important because or especially some important topics which we will cover today now. Why? Because which books I recommended you in my previous lectures, these books are depends on the language of the linear algebra. For example, I recommended you Advanced Microeconomics, Masculal, Rainey and Jhele, Rees, Grewal and the Rees. Third important and the fourth important book is Analysis of Microeconomics by Varian. So whenever you go in detail of these books or you want to cover some important topic from these books, so you have to know about these important concept of the linear algebra. Particularly in these books, if you don't have the concept of the optimization through matrices, so you cannot understand how these derivation are going and how they are taking the derivatives of the vectors and so on. Similarly, when we talk about the nature of the functions, what nature of the functions? For example, when we talk about the quasi-concavity or the concavity, so we should know about some important topics of the linear algebra. What are the important topics of the linear algebra which now we are covering here? These topics are upper contour, lower contour, level sets and the gradient vectors. Now why there is need to discuss these topics? It is another important debate. Inshallah, after completion of this lecture, you will be able to understand why we discuss these topics, especially in microeconomic theory. Clear? So today, first of all, everybody knows about whenever we plot any concave function, we have covered in my previous lecture. So the shape of the concave function will be look like this diagram. Concave function means, for example, any Cobb-Douglas function, it may be a concave function. Any CES, constant elasticity utility function, will be a nature of the concave function and so on. So any quadratic equation or any quadratic function which degree is more than 1, so you may have this kind of the shape, that is called the diagram of any concave function. Is that clear? Now from this concave function we will derive some important concept of linear algebra. What concept? Upper contour, lower contour, level sets and the gradient vectors. On the basis of these three important topics, we will be able to understand the concept of quasi-concavity, strictly quasi-concavity and quasi-convexity. So, and we have covered in my previous lecture why we assume our production function, our utility function should be a quasi-concave function. So now we are moving towards here. First of all, this diagram, everybody knows that if you have any background, if you have the background of the mathematics, either you have discussed at intermediate or the graduation levels, you know that this is basic diagram of any concave function. For example, let's say now we start first of all upper contour set. Upper, now for just a minute, ब्लैक मार्कर यूज करता हूं. अपर कंटूर, अपर contour first of all, yeah, sorry, just a minute. Level sets. First we will define level sets. Okay. What is the definition of level sets? A functional value of function f which consist all the points in the domain of f at which function has a certain value or take any 2 points at which function has same set of level or same value it is called level sets. Ab now you will be confused what a technical definition is this. This is very simple and the basic definition. If when we relate these concept or this concept with microeconomics. In microeconomics, in microeconomics, indifference curve that is called IC, isocont it is called IQ, iso profit line production possibility frontier PPF, P, F. These are examples of level sets. How you define these level sets? For example, this is commodity vector X. This is commodity vector Y. And we draw a level sets. It is called IC. How we draw this level sets? This level sets is based on concave function. That concave function is called Cobb-Douglas utility function. This IC based on Cobb-Douglas utility function. Ab now, what can be this nature of function? This nature of function, for example, like this one, f x y equal to x alpha y beta. This is nature of Cobb-Douglas utility function. Now that Cobb-Douglas utility function will be in nature of concave function, and when it will be in the nature of the concave function, we will have this kind of the shape which I have plotted here. And in this utility function, which is kind of the concave utility function, and we name it Cobb-Douglas utility function, we have different level sets. These are the level sets. These are level sets. Now, these level sets. This is one level set, for example, 1. This is another level sets, for example, 2, and so on. So these are multiple level sets. A functional value of function f, this function f, which consists of all the points in the domain of f. What is domain of f? Ultimately, these are domain of f, means there are multiple value of x here, there are multiple value of y here. So if I mark here in the subscript, it is a commodity vector xi, and this is the commodity vector yj, for example. So now we know that xi is consist of similarly x1, x2, and so on xn, and yj, it is a commodity vector y1, y2, and so on yn. So on the basis of these domain, we are able to plot different level sets. So what is the definition of all the points in the domain of f? In the domain of f, these are the domains of f. at which function has a certain value. Ultimately, function has a certain value of this level set, function has a certain value of this level set too, and so on. Or take any 2 points at which function has the same set of level or the same value. It is called the level set. So on the basis of these domain of the function f, we are able to plot different level sets, clear, and which are visible here. You can observe here, these are the multiple level sets which has at certain values of f. Now these are called level sets. Now what these level sets, these level sets may be in difference curve. If we talk about a utility function, these level sets may be isocont. If we talk about a production function, these level sets may be a iso profit line when we have a nature of profit function, and so on. These level sets may be a production possibility frontier when we define two different commodities, and so on. So it means that these level set we call the name of indifference curve, isocont, isoprofit line, and so on in microeconomics. Clear? Now why I name these are level sets? Because in muscular, in Rainey and Jhele and other books, sometimes they use the word of level set instead of the indifference curve. So a student may confuse why you are using these name of level sets, the name of level sets here instead of the indifference curve. That's why I am explaining you, because until and unless you are not able to understand the concept of these linear algebra, you will be confused at the time of reading these books. Now, okay, up for you have to clear about what is upper contour, lower contour, and the levels. Level set is now cleared. I think everybody is cleared about what is the definition of the level sets. Level sets simple सा एक define कर रहा हूँ कि function f has all the values with respect to the domain. यानी if you define, you find a value of function with respect to its domain, you are able to plot a line or graph. That line or graph is called level set. Basic सी definition here. And on the basis of these level set or this level set, we defined which area is called production upper contour set, which area is called lower contour set. Okay, right? So now we are moving towards a lower contour and upper contour set. First of all, I am writing a definition of upper contour and lower contour set. Clear? So मैं इसको अब रब कर रहा हूं. Okay. Okay, guys. We have plotted here, for example, this level sets. We plotted here. X commodity factor or we say that x1 commodity vector, and this one is x2 commodity vector. These are two commodities, and these commodities vector I can define x1 x11 x21 x31 and xn1. So this is the way to write commodity vectors. It is represented x1 commodity vector, and x1 commodity vector has these elements x1, x2, x3 and so on xn. Or you can write this one way, हम इसको इस तरह लिख लेते हैं x1 commodity vector, and similarly this is x2 commodity vector, clear? And so on. This is x2. It is not a square, remember, it is a way, it means it is a commodity vector x2. So x21, x12, x22, x32 and xn2. You got my point? There are two commodities vector x1 and x2, and these are the elements of these two commodities vectors. Now we have x1 commodity vector. Ultimately it has different n dimensional elements. Yeah, n elements. It is the set of n elements. Ultimately it is the set of n elements. It may be a column vector or row vector, whatever. Now we are not going in detail of which one, either it is a column vector or it is a row vector, because there we don't have discussion related to the multiplication and addition of the vector. That's why we are not focusing here कि it is either it is a commodity vector or it is a raw vector or the column vector. Clear? क्योंकि अभी हम इस डिबेट में नहीं जा रहे हैं. We have plotted a level set here. हमने एक लेवल सेट्स प्लॉट कर लिया. Clear? And this level sets is a, for example, Cobb-Douglas utility function. This level sets is this level set is drawn by on the basis of this Cobb-Douglas utility function, and we have marked here कि y f x y x1 and x2. So we have x1 alpha and x2 beta, and we defined any value. That value, for example, we represented by a. If we define any value subject or with respect to this function, and we mark here, let's say this value is here, a. All the values are here. They are less than this functional value. All the values lie here. These are greater than this functional value. So we can write, for example, this area f x1, x2 either greater than or equal to a. So all the values lie in this region, in this region, in this region, okay, in this region. They are they are at least at least as equal to a, and the values lie here. They are there are these are at most as equal to a. So when we compare, so when we defined upper contour and lower contour, so all the values lie in this region. They are called upper contour. All the values lie in this region. They are called lower contour set. So this is called upper contour set and this one is called lower contour set. So now I am writing the definition of upper contour and lower contour. So look at this definition. Upper contour set. How? A functional value, a function consists of all the points in the domain of f at which function has at least a certain value, it is called upper contour set. How can you write? I am writing or mentioning upper contour by u is a set xi or u. A function f defined over a which belongs to a real number, which belongs to a real number, and it will be it will be upper contour set when u xi belongs to R such that f xi greater than equal to a, upper contour set. And similarly, lower contour set, we just change, we have just slightly changed in this definition. Instead of at least, we have at most. At most, a certain value, it is called lower contour set. So how you can write a lower contour set? Lower contour set. So I can write here lower contour set. Just a minute. Lower contour set. Lower contour set. L equal to xi belongs to R such that fxi it is a lower contour set. Okay, for example, if you have equation of circle, why I am taking the example of equation of circle, ताकि आप लोगों को it will be more clear, आपको ज़्यादा clear हो जाएगा, क्योंकि equation of circle is very familiar or very common equation. What may be the equation of circle? Equation of circle is like this one, y equal to equation of EQ, equation of circle is y equal to fx x1 x2, it is x1 square plus x2 square. This is kind of the equation of circle, and we can plot in between 4 quadrant. For example, this one, this is kind of equation of circle. This is equation of circle now, for example. Okay, and this is x1 and this one is x2. here 0, it is origin and 0. Again we mark any value around this function, we mark here, we select any point, this is any functional value a, functional value which is equal to a, so I just equal to this one, this is a. Now all the values are inside this circle, these are less than this one, so lower contour, lower contour set. All the values lie outside the circle, upper contour sets. So in very basic, in very simplest way, if we compare functional value subject to this value of a, subject to this functional value of a, if the value is less than, if the functional value is less than this value a, will be the part of lower contour set. If functional value of f greater than this functional value a, are the part of, all the values are the part of upper contour set. So now you can compare with example of circle and with example of the Cobb-Douglas production and other kind of the function, how you can define a upper contour and lower contour set. So first of all you should clear about the level sets. What are the definition of the level sets? I have now cleared. Now we are cleared about the definition of the level sets. Why we use the level sets? We use the level sets to draw a isocon, to draw a indifference curve, to draw a isoprofit line. Similarly, why we define the upper contour and the lower contour set? We are now cleared. So what is the example of lower contour set? The example of the lower contour sets are budget set, not the budget line, budget set. All values lies under the budget line. All values lies under the budget line, which is, budget line is level set, it is called lower contour. We have example, and similarly case of isoprofit line, etc. Clear? So these are the example of lower contour set. So how you can write? You can plot this one. This is your budget set. X and Y this year budget line, which is px over py. So these all are lower contour set. Similarly, upper contour set, we have the example of the upper contour set when we plot a edgeworth box diagram. So in this diagram, we have the example of the Pareto optimality. Every nation wants to maximize his efficiency or want to achieve overall efficiency. So in this regard, we have the example of, we can relate this concept with the definition of upper contour set when we have this kind of the concept of overall efficiency. Clear? So guys, I think it is enough, and I assume that every topic of lower contour set, upper contour set, level sets, everything will be cleared about. Now, one important thing. What about the gradient vector? Gradient vector is that it is represented by slope of level sets at particular point, and we can represent it by this gradient vector fxi dash, or so gradient vector represented by slope of level set at particular point. So we called it a gradient vectors. So now every topic is cleared: upper contour set, lower contour set, level sets, and the gradient vectors. Clear? So on the basis of these three concepts, we will move towards a quasi-concave function and quasi-convex function. So in my third video, we will discuss about how you can define the quasi-concave, quasi-convex on the basis of these upper contour, lower contour, and the level sets. Clear? Thank you so much. Allah Hafiz.